right, so TLS and HTTPS. How many people have heard of SSL? All right, how many people have heard of TLS? How many people have heard of TTYL? Talk to you later. So SSL is like the predecessor to TLS. TLS is like the new way to do security, and that's the way you need to use today. So SSL is dead. TLS is the new way you talk about that, transport layer security, and that's how you do HTTPS and get this HTTPS up here and encrypt all of the transmission between the client and the server. So it's encryption where keys are involved, and if anybody intercepts it, they can't unencrypt it unless they have a key or unless they're the NSA. And Eunice and I were just talking about how the NSA is probably secretly playing a part in this easily, so that they could read and unencrypt all HTTPS content. We'll show you how they're probably doing that. And if they're not doing that, then you should hire me, NSA. And here's a great takeaway for you, because I know how you can gain access to all encrypted HTTPS content very easily, and it won't cost you much money at all. Do you hear that, Edward Snowden? TLS. So that's what gives us HTTPS. There's a lot we could read about it. I've done some reading on it and highlighted some of the things. But transport layer security and its predecessor, SSL, right? That's the main thing there. And they use certificates, and it's asymmetric cryptography. How many people have studied cryptography in here? Right? How many people have not? Okay, cool. So I could tell you anything, and you'll believe me, or you'll take it with a grain of salt, because I'm learning this stuff too. But so there's symmetric and asymmetric cryptography, and I'm not sure I have a clear understanding on this, because it's cryptography, so it's got to be complex, right? And even if you think you understand it, that probably means you don't understand it. It's like that famous quote about what are those new computers? I'm totally spacing on this all of a sudden. They're supercomputers, they're quantum bits, quantum computing, right? And one of the world's leading quantum physicists said, if you think you understand quantum physics, you don't understand quantum physics. Like, that's one of the world's leading experts on quantum physics. If you think you understand it, you don't understand it. Basically, there's no understanding it, is what he's saying.
Have you studied qubits?
I haven't studied it at all. Have you?
Well, I hear a little bit.
Cool.
Like I saw a video of a visual representation of what a qubit would look like.
Yeah, it's a pizza and a bagel at the same time.
They're like building hardware right now.
No, Google has a quantum computing lab with D-Wave computers, and it's already running. And you can watch Google. You could Google quantum computing, and you'll have your mind blown, right? Like, they have a quantum computing lab that's already up and going, quantum computers, and they're doing stuff with it, which is going to change your world and change our world in ways we don't even know. So it's asymmetric cryptography. Authenticate the counterpart with whom they are communicating, and to negotiate symmetric key session. Right? Authenticate the counterpart with whom they're communicating and negotiate asymmetric session key. So to do this, you need to have a certificate, and there's something called certificate authorities. And it's necessary to verify the relation between a certificate and its owner, as well as to generate, sign, and administer the validity of certificates. So that's some of the key points you want to take away here. Right? TLS is the new SSL. This is asymmetric cryptography. And certificate authorities are required to, issue certificates. And so public key cryptography is also known as asymmetric cryptography. All right, so public key cryptography. And you could read about this whole thing on Wikipedia. But this is basically it right here. I really like the image. It's like, give me the kindergarten picture book, please. In an asymmetric key encryption scheme, anyone can encrypt messages using the public key, but only the holder of the paired private key can decrypt. Security depends on the secrecy of the private key, right? So here we have a public key. I make that accessible to everybody in the world. And that allows you to take something and encrypt it and send it to me, all right? I am the only one who can decrypt that. Okay, I'm the only one who could decrypt that. So I receive it and I could decrypt it. Somebody else gets it, they can't decrypt it with the public key. But if they have my private key, they could decrypt it. So this is asymmetric. Asymmetric means like it's not balanced, right? It's one way. Symmetric would be balanced, you know, kind of both ways. Asymmetric means the encryption can only go from one person to me, right? Well, that's not going to work because we need HTTPS and we need things to be encrypted coming from the client to the server. And when the server sends a response back to the client, we need that to go back the other way. All right, so we're going to see how that happens, where we get this arrow going both ways. But here, where all right, we'll see this first. So here in the blah 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 key exchange scheme, each party generates a public-private key pair and distributes the public key. After obtaining an authentic copy of each other's public keys, Alice and Bob can compute a shared secret offline. The shared secret can be used, for instance, as the key for a symmetric cipher, right? And so if basically we have both of these operations, I have a public key, you have a public key, we could then have communication going both ways, right? We understood this, no problem. Well, let's just have a way where, you know, we could get it going both directions. And so basically, you know, I take the public key and private key, combine them, and I get, you know, this and then that, right? And so then we have something where combined keys allows it to go both ways and becomes symmetric. All right. So symmetric key algorithm are algorithms for cryptography that use the same cryptographic keys for both encryption of plain text and decryption of ciphertext. The keys may be identical, or there may be a simple transformation to go between the two keys. The keys in practice represent a shared secret between two or more parties that can be used to maintain private information link. The requirement that both parties have access to the secret key is one of the main drawbacks of symmetric key encryption in comparison to public key encryption. So certificate authority. In cryptography, certificate authority is the entity that issues digital certificates. A digital certificate certifies the ownership of a public key by the named subject of the certificate. This allows others to rely upon signatures or on assertions made by the private key that corresponds to the certified public key. In this model of trust relationships, a CA is a trusted third party, trusted both by the subject owner to the certificate and the party relying upon the certificate. Many public key infrastructure schemes feature CAs. I'm not explaining this well. I kind of fell apart right here. You got a way to approach it, Daniel? He's like, I haven't thought about this.
Ish. So the combined secret, you did pretty well in explaining that. They both share with each other a public key, and they've got their own private key. And they can use that to get themselves a way of talking back and forth. There's secret. Whether that's through combining them and creating a shared secret for symmetric encryption, or by just simply both of them encrypting using the other person's public key so that only the other person can decrypt it. Whatever the case may be, they can now talk securely. The certificate of authority is to verify that the public key that you're getting from the server is indeed the public key from that person. Otherwise, you could have some sort of man-in-the-middle attack where you're trying to go to Google, but it's someone else who arrives there and they give you a public key. You have no idea. Without a certificate of authority, you have no idea that public key is not Google's public key.
So you're Alice, and Bob says, here's my public key. And Alice says, thank you very much, Bob, right? But, you know, that just got sent, you know, like Alice and Bob are both blind to each other. This just arrived over the network. How do I know that that person who says they're Bob, that information coming in saying it's from Bob, a letter saying, hey, this is from Bob, right? How do I know that is actually from Bob? And that's where a certificate authority comes in, right? Because Bob's going to mail a letter, and if it just arrives and nobody else has vouched for it, anybody could have mailed me that letter with the public key in it, right? But if Bob mails me a letter and Bill Clinton or Ronald Reagan or, you know, Obama or George Bush says, yes, this is from Bob. It's like, well, hey, George Bush says from Bob. It must be from Bob, right? George Bush vouched that this came from Bob. He's the certificate authority. He kind of like put a seal of approval. This is definitely from Bob, right? However, if P. Diddy signed it and said, this is from Bob, or if I signed it and said, this is from Bob, you might be like, well, Todd's saying it's from Bob, but is Todd trustworthy? Right? So whoever the certificate authority is, right, like verifying that this is actually from Bob, that's kind of like a weak point. So anyhow.
One note of something pretty funny is that a lot of companies that function as certificate authorities will count as their own certificate authority. Like Google is the Google.com certificate authority.
We're Google, and we're signing our certificate saying we're Google because we're Google. And browsers come with preloaded list of trusted certificate authorities. So, right, there's a list out there that companies, they go through some rigmarole to become a certificate authority, and then they could sign certificates, and some of them charge tens of thousands of dollars a year to put their seal of approval on a certificate, right? And some of them are free. And it doesn't matter, ultimately. It's just a list, and if one of those certificate authorities is in your list that your browser uses, right, of a company that could sign it, then your HTTPS is not going to look like this, right? Here is an unsigned certificate. Certificate authority, no certificate authority signed this, so I try to use HTTPS, my browser checks the certificate, right, and it's like, wait, no CA signed this. Whoa, this might not be secure, right? We are still encrypting everything from both ways, but that encryption hasn't been verified that the key came from Bob, right? It hasn't been signed. And so if you get a certificate authority sign it, then that stuff goes away. That's all. And really from a user standpoint, nobody's like, hey, did Bill Clinton or George Bush sign it, or was that Todd who signed it saying? It's like George Bush, Bill Clinton, and Todd are all equal if they've been added to this list in the browsers, right? So it doesn't really matter if you pay $10,000 a year or get the free version, which is right here. It looks totally janky. They offer it free. They're in like Israel or something, right? It's like some companies like, oh, we'll offer them for free. And it's like total like 2001 website. What year did you put on that website? That's like 2004. Isn't that funny how you could look at a website and know what period it's from?
So the list of certificate authorities also has the public keys.
Oh crap, dude! I'm not recording. We gotta start over. No, I am recording. Oh, good. I just lost my place though.
So the list of certificate authorities that your web browser's got also has the public key for them, so you know that you can trust that certificate authority. You just have their public keys memorized.
So I don't totally understand all that, like I said, but I was looking at Y Combinator. So it's like a Hacker News, Y Combinator. You can check it out. And I saw that there's this let'sencrypt.org, which is trying to make encryption accessible to the world, and they look a little bit more legitimate than Swiss officer's knife of digital certificates. So I think maybe you'll be able to get them for free from this more legitimate looking website, which probably means it's run by the NSA, right? Because if the NSA is a certificate that signs all of them, they, I think, also have a key to then decrypt all of it. I'm not sure if that's the way it works, but I think that's the way it works. And that would be brilliant, right? Like, oh, we'll sign your certificate for free for everybody. And the most popular certificate signer out there is, I can't remember, but I think it's like the Norton people. So how do you get a certificate? You could just generate one like this, right? So this is in crypto, and you could just run this at the command line, and it'll generate an unsigned certificate. So as you're playing around with this, we're going to do that. And here's like the general syntax, and here's an example of how you use it. So the only difference is here I've set host to localhost. And since we're serving locally, let's put localhost as our domain, right? But if you're doing this somewhere else, you'd put your domain in there.
Please note that this go env go root, I believe that only runs and works that way in Bash, the Windows command line. You'll just have to put the actual value of go root there.
Yeah, and so where's that looking? Is that looking to my workspace or to the, and am I using the right word here, SDK? Is it looking to the SDK or the workspace?
That would be where the go binary is.
The go binary, that's the correct phrase. I knew there's a better one.
I think you could just use $sign go root.
Yeah, yes, you could, but that would only work on the Bash. I believe Windows, you could put was it percent go root percent would work, I believe.
Oh, yeah.
All right, so when you run it, I wrote a cert PIM and I got a key PIM. What does that mean? And I could kind of like see them here. There's my key PIM. That's the key to the kingdom. That's my private key. Don't share that with anybody, right? And then over here is cert perm. And this is the public key. I think I have like 92% certainty on that. Is that your take on that too?
I think so.
Yeah. And then here's that big base 64 data chunk. And then we have listen and serve TLS. So instead of just listen and serve, it's listen and serve TLS, which means I'm going to do, HTTPS. So acts identical to listen and serve, except that it expects an HTTPS connection. And we have, our address string, and we have our handler, but then we also have our cert file and our key file. So those are the two things that we did here. There's the cert file and there's the key file. And so we just give those, and then it does all of the checking and everything, right? And returns an error if there's an error. And so here's an example of that in action. And that's a same example right here, right? Crazy old port 10443. And 443 is the port for HTTPS. 80 is the port for HTTP when you're actually live, right? That's where you're supposed to serve. Checking on that. Like 92% certainty on that one also. And then here we've got what's going on? HTTP listen and serve, listening on port 999, just straight up listen and serve, right? And then that's a go routine right there. So it's going to run this process. And then we also have HTTP listen and serve TLS, right? So it runs this process. It doesn't wait here. And then it comes right down here and it runs this one also. So it's running two listen and serves. And so this one's on 999 and this one's on 10443. And we pass in those two files. And then we have handle func /handler. And about to listen on 10443, go to that place. And so if we go there, then this is the handler that runs. Set the content text plain. This is an example server, slice of bytes. Turn that into slice of bytes and write that. Write it, w.write. It's kind of an interesting way to do it.
He's manually using the write method on a writer. So normally just use IO write string or something.
Mm-hmm. But that's straight from the example, so brought it over the way it is in the example. And so there I ran this in my folder, got my certain key where I want to run this, so those files have to be right in the same folder, if they're set up this way, like, hey, that's where it's located. And then I could go to that, and so when I go here, it says your connection is not private, because I don't have a certificate of authority who signed off on it. I could click advanced and then say to continue, and it would show me. But that's showing HTTPS. HTTPS is in use. It's just not signed, a signed CA. So this is kind of where TSL sits in the web stack or whatever of the network, right? We looked at TCP and HTTP. It kind of goes right between them. So because of that, we could use all the stuff we've already been doing. That's somewhat of a mystery to me too. But that's the way it's explained to me with no further a little bit more explanation. But it kind of makes sense.
Yeah, the network stack is designed in such a way that each layer touches the next layer down as little as possible, and next layer up as little as possible, so that you don't have to understand it. I mean, you really don't want to have to understand the network layer where all the wires are in order to be able to understand how to make a web page go across HTTP. It's probably not worth studying. So they designed it in such a way that each layer almost has an interface between it. That way you don't have to worry what's between, or what other layers have got.
So this layer knows how to work with HTTP and TCP, right? And so we could just pass it TCP stuff, and it says, oh, I know how to do that, and passes it straight to TCP.
Yes.
Or whatever. That's cool. Thank you. So same kind of thing here, Go, right? I think that's the exact same file. I'm just pointing out that that's a
Just doing
Go
a
routine. And here is, oh yeah, great, cool. So here we're doing a redirect. So if you come in and you're not on HTTPS, right? If you're not on HTTPS, then you redirect and you go to HTTPS. So HTTP redirect handler. It's just a function of the net HTTP package. It takes where do you want to go and then the status code. And then here we have another way that you could have written that, which is HTTP handler func, and then create a func, right, where there's HTTP redirect. So before we were using HTTP redirect handler, here we're using HTTP redirect, and we could do it like that. So there's a service called Cloudflare, and we're going to stop this recording of the video. I think that's why I freaked out that it wasn't recording, so I had a screenshot. I'm like, that was a screenshot, right? That's not actually, that's a picture. We're going to watch this Cloudflare video, so if you are out there in the world, go watch this video.